In this video, we will cover the standard Proctor Compaction test. The aim of this experiment is to determine the compaction characteristics of the given soil. In order to perform this experiment, you need the following: a caliper, a cylindrical mold, a manual rammer, a straight edge, and a balance. First, measure the diameter and the height of the mold. Then, measure its weight. Place a layer of oil on the interior wall of the mold. Place the cap on the mold. Place the mold on a solid concreted floor. Start pouring the soil into the mold in 3 layers. The soil should be mixed with a defined amount of water in a uniform manner and left for curing for 24 hours before performing this test. After pouring each layer of soil, perform a 25 ram on the soil surface in a uniform manner. Remove the mold's cap and remove the excess soil using the straight edge. Measure the weight of the mold altogether with the compacted soil. Remove the soil from the mold and find the water content, which we had covered in a previous video. Click here or on the link in the description box. You should repeat the experiment with the same soil, however, you should mix it with a different amount of water. Now the calculation part. We have the following data which has been obtained from a laboratory experiment. So first we need to obtain the volume. First you write equal, then select the height, then time, pi. You write pi, then open parentheses and close it. This is how you write pi in Excel. Then time, the diameter square to the power of 2 divided by 4. This is the volume, but it is in millimeters since we have diameter in millimeter and height in millimeter. So divide by 1000 to get it in centimeter cube. Now we need to find soil masses. To obtain this, write equal, select the cell of mass of the full mold, and then write minus, select the mass of the empty one, and you get the answer immediately. Then, and click and drag. Now we need to find the bulk density, which is equal soil mass divided by volume. So again, write equal, select the soil mass, and then divide it by volume. Since volume cell is always here, click before the letter C, put a $sign, and after the letter C, put another $sign. Now click and drag. To find dry density, we need to use this formula, which is equal to bulk density divided by 1 plus water content. So again, write equal, select bulk density divided by 1 plus water content. We have it here, but you need to put the parentheses. Now again, click and drag. This is dry density. Now you need to draw it. Go to insert menu, then click here and select this one. Now right click on it, select data, add, right click here on select range. This is X value, which is our water content. Click enter, and for Y series we will select the dry density. Click enter. Okay, as we can see, the scale is too much big. Select X axis, then right click, format axis, make the minimum value 0.1 and the maximum 0.2. It's okay, close it. Now as we can see, the dry density is 1.86, which is right here, the maximum dry density, and the optimum water content is something like 0.15. Now you need to draw the saturation lines for air content of 0 and 5% and 10%. So anywhere, write 0, 5 and 10%. To draw this line, you need to use this formula, which is rho dry equals GS times rho of water times 1 minus air content divided by 1 plus water contents times specific gravity. So to do this, you have to assume some amount of water content. We will assume 0.15, 0.17 and 0.19. So we have rho dry, we click equal, rho dry equal specific gravity, which is 2.69. Since it is always here, you have to fix it in its place by putting dollar signs before the letter and after the letter, and times 1 minus air content, which is 0 in this case, times the rho of water, which is 1, should put times, divided by 1 plus, put the parentheses, 1 plus water content times specific gravity. Again, fix it by putting dollar sign, and close the parentheses, click enter, click and drag for the other one, and for the rest just copy the formula and put it here and change the 0 to 0.05, which is 5%. Click and drag again, and also for the 10, same procedure is applied. Paste the formula and change the 0 for 0.1, which is 10%. Click equal, click and drag. Now to draw it, right click, select data, add, on x-axis select water content, for y-axis select the dry density. Okay, another add for the 5%, for x-axis select the water content that we had assumed, and for the y-axis select the 5% dry density, click OK, and another add for the last one. X-axis again the same, y-axis this one, click OK. And by that we were able to determine the compaction characteristics of the given soil.